Okay, we're really getting back to basics on freeze drying today. The topic is, what is freeze drying? What is it? Hi, my name is Gene from Suntour. Welcome to my video. Yeah, as basic a question as you can get. What is freeze drying? So to start off, if you hear the term lyophilization, it's the same thing as freeze drying. Freeze drying is an American term for a process I think that was developed in Europe, and they have different nomenclature over there. So that's what we call it in both places. So what it means is that you are going to dry your product while it's frozen, hence freeze drying, which in my opinion seems a little bit more descriptive than lyophilization. But hey, that's the American way, right? So you're drying product while it's frozen. So imagine if you're in Denver, when you're boiling water, the water boils there at a lower temperature than it does in, let's say Charleston, South Carolina, where the atmospheric pressure is nominal, right? 29.92 inches of mercury or 14.7 psi I guess, psi absolute. But if you keep lowering the pressure, right? Say Denver, maybe if you go to the Himalayas, it'll boil at even a lower temperature, right? But if you keep going lower and lower in pressure, the boiling temperature will keep going lower and lower as well. Now you have to do it in a vacuum chamber, right? Because you can only get so low in pressure on Earth, let's call it. Obviously, you can get pretty low out in space. But if you put your product into a vacuum chamber, you can get the pressure really low, and you can go so low that remember the boiling temperature goes lower with the pressure. And you can get so low that it actually crosses 0 degrees C, or in America 32 Fahrenheit, where the product will actually, the water in it will actually freeze into ice. And you can actually create ice simply by drawing vacuum on it. I've done it, right? I've been in the vacuum technology world for a long time. I have actually done experiments where I've created ice simply by drawing vacuum on it, on water. So once you go below the freezing point, you're no longer really boiling water, you're sublimating it, right? This is where it's going from solid to gas directly. Now you can think of another substance you might be familiar with that does this naturally. That's dry ice, right? So if you have a piece of dry ice on your countertop, it will actually just turn into carbon dioxide vapor directly from the ice. That's because it is cold enough at its normal vaporizing temperature at atmospheric pressure that it keeps it in the frozen state. So in order to actually have CO2 liquid, you have to have it in a pressure chamber and at a warmer temperature where it's actually above the freezing temperature. That was a little sidetrack, but you get the point, right? So once you're below the freezing point, you can keep going lower and lower and lower in pressure, and guess what? The temperature will continue to go lower. So that's how you end up with freeze drying, right? You're just drying the product while it's frozen. So that's it, right? You just pull vacuum in a chamber, and all the water vapor just comes out of the ice in your product, and it goes out through the vacuum pump, right? No, no, that's not what happens. I have heard that story, and it made my, I don't know, my shoulders bunch up when I heard it, because no, that is not what happens. You cannot vaporize anything without putting in heat. It is the laws of physics, thermodynamics specifically. You have to put in the heat of vaporization, which is the amount of heat that's required to take those molecules that are kind of stuck together, right? Imagine they're like little magnets, right? Because the water molecule is not linear. It's actually got a bend in it, right? The oxygen's at the corner of the V, and the two hydrogens are at the ends of the V, at either end. So the oxygen's a lot bigger than the hydrogen, so it's got more electrical charge, if you will, and that creates up this little like mini magnet, if you will. And so if you can imagine you've got a pile of iron filings on your desk, you just pick them up, right? They kind of flow through your fingers. But if you put a magnetic field on it, right, they all kind of stick together. And then if you want to pull them apart, you have to actually pull them apart. You have to add energy to get them to pull apart. Same thing in water, right? So in order to break those little weak bonds between the water molecules, you have to put in energy, and that energy is called heat. So what is heat? It's just a measure of how fast a molecule is vibrating. And you can measure that with a thermometer. But there's a type of heat where temperature just doesn't change even though you have to put in a lot of heat, and that's called latent heat. And there's a couple of different ones. There's the latent heat of fusion. That's where you go from solid to liquid. And then there's the latent heat of vaporization, where you go from liquid to gas, right? And you can just look up these terms in a chat bot if you like, learn all about it. Maybe I'll do a video on that sort of stuff by itself in the future. But for right now, you're just going to have to take it as the laws of physics. Now, how much heat is that? It's a lot, right? So, and I have a video that's all about how heat works in the freeze drying process. So check out that video. What is most important here is that the latent heat just takes a lot more energy than the sensible heat, right? So it takes a lot more heat to boil water than it does to change it by a degree. How much more? 533 times more energy to boil it than to change it by a degree. So that's a lot. That means that even though you put in heat while you are at vacuum, you never actually have the temperature rise in your product because you're pulling the heat out faster than you put it in. Well, you're pulling it out exactly as fast as you put it in, to be precise. And all that heat is going into the change in phase, which is in this case sublimation. Okay? So the product remains frozen the entire time that you are freeze drying. So that, if you remember right from my video, which is all about the 4 reasons why you should freeze dry, is one of the big key drivers to the advantages of freeze drying. That being that because the product is frozen, you're going to have all of these advantages, right? Go watch that video. It's actually very short and fairly informative if you're on the fence about freeze drying. So while the product is sublimating away, it's creating this cold wind in the chamber, right? So the water vapor comes out of the product, and it's ice cold. It's the same temperature as the product inside in the ice where it's vaporizing. So it blows this cold water wind onto the shelves that are holding it and that are above it, that are radiating heat down on it, cools them, and then the system has to add more heat to the shelves to make up for that loss in heat in the shelves. And that's how it works, right? So you can't just put product into a chamber and draw a vacuum and have all the water vapor go out through the pump. In fact, if you notice when you're operating a freeze dryer, almost all that water vapor ends up as ice, either on the inside of your chamber or on your vapor condensers. That's because it does a lot more water pumping, if you will, than your vacuum pump can. How much more? Thousands, tens of thousands, hundreds of thousands of times faster water pumping capacity for a cold surface than for a vacuum pump. I am going to do a video that's exactly about that topic. You can actually find an article that's all about that on my website. Just go to suntour.com and click on the freeze drying info tab. You'll see blog articles that cover most of my topics. Okay, so once your water is all sublimated away, you go from the state where you have sublimation happening into a state where you still have some water left in there. Because you remember you got all these little tiny magnets, right? Well, they stick to everything. They stick to all the surfaces, including your product. All the surfaces inside and outside of your product. So you have to get that moisture out, because when you're done with sublimation phase, you still have 9+% moisture by weight, and that's not dry enough. That's not freeze dried. So you have to get that out of there. And how you do that is in the phase. So you're going from the sublimation phase into the what I call desorption phase, where you have to desorb that water from the product. I've got a video that's all about sublimation versus desorption, and that's in my video called The 2 Phases of Freeze Drying. Check out that video, and you can learn all about it there. Or you can just put it into your chatbot, right? So my chatbot is of choice is Grok 3. It's amazing the level of answer that I get from that. But okay, so I hope you got some information out of this video. So what is freeze drying? Let's put it into a summary. Freeze drying is when you dry your product while it's frozen. You do that by having it at low pressure, pressure that's low enough that the boiling temperature is less than freezing. You put in all the heat that you need to get all the water vaporized, which is a lot, 530 times more than it takes to change temperature. And then when it's all dry, you desorb the final bits of moisture that's left. And then what you end up with is this really crispy, crunchy, snappy product, right? So, but that's not the only advantage you get. In fact, you should watch my video that's all about the 4 reasons that you should freeze dry. Okay, so yeah, I hope you got value out of this video. I hope it was entertaining for you. And so this is Gene at Suntour. Check out my other videos, and we'll see you on the next one.